This section introduces the fundamental hardware and components of the AUDMAX system. It is designed to familiarize technical personnel with the basic operations and features of the AUDMAX Master, booster panels, and associated modules. Topics include system installation, component connections, and basic configurations. By the end of this training, participants will have a solid understanding of the system's structure and capabilities, enabling them to handle straightforward installations and hardware configurations with confidence. There are only a few parts that make up the entire AUDMAX system. The AUDMAX Master, required for a base system. AUDMAX BP, booster panels with the same function as the Master but without the main display door. AUDMAX RM, remote mic. AUDMAX LOCR, local operating console, duplicates the main display of the main panel. Optional amplifier, QAD30. Optional zone splitter, QAS2X8, and programmable button display adders, the QAZT5302DS and QAZT5348DS. The main panel consists of an outer door equipped with a microphone and control switches, while the interior houses the power supply, mainboard, and a QAD30 amplifier. There is space available for batteries up to 18 amp hour. Let's take a closer look. The main board serves as the central hub for all connections, including power, communication, and NAC outputs. Each terminal is clearly labeled on the circuit board for easy identification and wiring during installation. Understanding the layout and function of these terminals is essential for proper system setup and operation. In the following slides, we will take a close look at the specific connections and their configurations. The main board circuits, switches, and connections. Let's zoom in and take a closer look at these. Looking at the top of the main board, we see the field wiring connections that are provided with removable circuit block connectors. For quick reference, the circuits can be identified by the permanent labeling on the main board. LED status indicators associated with each circuit provide visual feedback on circuit operation or fault conditions. The remote microphone connections on the main board require careful attention to ensure proper functionality. These connections include two shielded twisted pairs, one for microphone audio and one for RS-485 communication. Additionally, a third pair supplies 24 VDC power. The connections originate from the main board and are daisy-chained to each remote microphone, with a maximum of 6 supported. To maintain signal integrity, shield continuity must be preserved, and shields should be terminated only at the main panel. This setup ensures clear and reliable communication across the system. The AUDMAX Master Panel supports 2 independent initiating device circuits, or IDCs, for relay input activation. Each circuit can be programmed to trigger specific zones and play corresponding messages. These connections are configured as Class B and supervised using 3.9K resistors. This method allows integration with external devices or panels, providing a versatile and reliable way to automatically initiate the system. The AUDMAX Master Panel features auxiliary contacts that provide remote monitoring capabilities. These Form C contacts, which include normally open and normally closed options, can be used to monitor alarm status, AC power faults, and common system trouble conditions. LED indicators located below the contacts visually display the current state of each relay. This functionality enables integration with external systems and ensures real-time visibility into the panel's operational status. The main panel uses an RS-485 communication bus to interconnect with up to 5 booster panels. This communication can be configured as Class A or Class B. The RS-485 bus ensures reliable data transmission between the master panel and booster panels, enabling coordinated operation across the system. This is the only wiring needed between panels for distributed audio functionality. Proper wiring methods and panel addressing are required for maintaining communication and overall system performance. A signaling line circuit connection, or SLC loop, allows the master panel to integrate seamlessly with compatible addressable fire alarm control units, such as the Secutron MR400 or MR401 panels. This connection enables detailed monitoring and control of the system, including multi-zone activation and message delivery based on specific inputs. The SLC loop connection can be Class A or Class B, depending on the installation requirements. This advanced feature ensures that the system can respond dynamically to addressable fire alarm inputs, enhancing the overall coordination and effectiveness of emergency communication. The synchronization inputs on the master panel allow integration with external NAC circuits for system activation. Each sync input can be programmed to initiate specific zone activations and play pre-programmed messages. These inputs can be wired as Class A or Class B circuits. For Class B wiring, the supervising end-of-line resistor is placed on the unwired terminals. The synchronization outputs on the master panel are used to transmit synchronization protocols to connected booster panels. Each sync output connects to the sync input of the next panel in the system. In a single-stage configuration, only one sync connection is required, while dual-stage systems utilize both sync outputs. These circuits are wired as Class B and ensure synchronized operation of notification appliances across multiple panels. The master panel's sync output 1 is connected to sync input 1 on the first booster panel. Similarly, sync output 1 of the first booster panel connects to sync input 1 of the next booster panel, maintaining a daisy chain configuration. This method ensures that all panels operate in harmony, delivering synchronized audio and visual alerts throughout the system. Dual-stage systems can utilize sync output 2 for second-stage operations. The master panel includes two onboard notification appliance circuit outputs. Each circuit is rated for 2.5 amps at 24 volts DC and supports both Class A and Class B wiring configurations. The NAC outputs are compatible with common synchronization protocols, including MGC, System Sensor, Gentex, and WeLock, ensuring seamless integration with various notification appliances. These outputs provide reliable activation of synchronized strobe circuits, making them a valuable component of the emergency communication system. The master panel comes equipped with a factory-installed microphone wired directly to terminals on the left side of the main board. This built-in microphone allows for live paging and announcements to the configured zones. The microphone's connection is integral to the system's operation, ensuring reliable communication during emergencies. The main display on the master panel is connected via a factory-installed 10-pin ribbon cable. This connection ensures communication between the main board and the display module, enabling operators to access controls, indicators, and system statuses. Proper care should be taken during installation and maintenance to ensure the ribbon cable remains securely attached, preserving the functionality of the display. The master panel features a USB Type-B port located in the bottom left corner of the main board. This port allows connection to a laptop for system configuration using the MGC ECS configuration application. Through this interface, installers can customize system settings, program zones, and upload audio messages with ease. The master and booster panels use a dip switch bank to set a unique panel address. This address is configured using an 8-bit binary system, ensuring that each panel within the system has a distinct identifier. Proper address assignment is critical for maintaining communication integrity and avoiding conflicts between connected panels. Refer to the installation manual for detailed guidance on address configuration. The master panel includes a reset jumper located near the panel buzzer on the lower left corner of the main board. This jumper, labeled SW7, allows for a manual system reset by shorting its pins. The panel reset function is useful during maintenance or troubleshooting, ensuring a quick and effective method to restore the system to operational status. The main board includes two dedicated ports, labeled P5 and P6, for connecting amplifiers. These ports are designed to support the QAD30 amplifiers, which mount directly onto the main board. Ribbon cables provide the connection between the amplifiers and the ports, ensuring reliable power and data transfer. Proper configuration of these ports is needed for audio output. The P7 connector on the main board is reserved for the QAS2X8 zone splitter module. This module expands the system's capabilities by providing 8 independently controllable output circuits. It is important to note that the P7 connection is exclusively for the zone splitter module and should not be used for any other purpose. The main board includes battery spade lugs for connecting backup batteries. These connections are used with factory-provided battery leads to ensure secure and reliable power delivery. Properly installed batteries provide backup power during outages, maintaining system operation and ensuring continuous emergency communication. The panel supports battery charging capacities up to 75 amp hours, offering flexibility based on installation needs. Master and booster panels support the installation of amplifiers and a zone splitter module directly onto the main board. The QAD30 amplifiers connect to the P5 and P6 ports, while the QAS2X8 zone splitter connects to the P7 port. Each amplifier must be configured to match the panel's programming settings, and the splitter allows for independent control of up to 8 output circuits. Ensuring proper mounting and configuration of these components is essential for reliable system performance and scalability. The QAD30 amplifier provides 2 independently configurable circuits for audio output and can be wired as Class A or Class B. Each circuit or zone can output up to 30 watts of power, but the total power shared between both circuits cannot exceed 30 watts. For example, if Circuit 1 is loaded with 23 watts of speaker devices, Circuit 2 can only support up to 7 watts. This design allows for flexible distribution of audio power across zones, ensuring efficient use of the amplifier's capacity. The system supports the use of a backup amplifier to ensure uninterrupted audio output in case of a primary amplifier failure. When configured in the software, the backup amplifier's output 1 is wired to the primary amplifier. This redundancy guarantees that critical audio notifications, such as emergency messages, are maintained even if an amplifier experiences a fault. Proper configuration and wiring of the backup amplifier is needed to provide for this application. The QAS2X8 zone splitter adds 8 fully supervised output circuits to the system, providing greater flexibility in zone control. Each circuit can be independently turned on or off and configured to receive audio from one of 2 amplifier inputs. This feature allows for targeted messaging and optimized zone management, ensuring precise audio delivery for diverse emergency communication needs. This slide demonstrates the versatility of the QAS2X8 zone splitter. In this example, 2 separate audio sources are connected to the splitter, allowing zones to be programmed to play different messages simultaneously. Each output can switch between input 1 and input 2, offering dynamic and customizable audio distribution. This application is ideal for complex installations that require multiple messages to be broadcast to distinct areas. The QAS2X8 zone splitter is highly versatile, offering several application options to meet diverse installation needs. Using a single audio message setup, up to 9 controllable output circuits can be utilized, combining 1 direct amplifier output with the 8 outputs of the splitter. In this scenario, amplifier output 1 is used as a direct speaker circuit. Amplifier output 2 is connected to input 1 on the zone splitter and is available to be switched onto any combination of the 8 outputs on the zone splitter. Note, the total load on the 8 outputs is limited by the connected input and should not exceed that capacity. For more advanced configurations, 2 amplifiers can feed the splitter's inputs, providing 10 output circuits. This setup uses an output from each amplifier as a speaker circuit and the other output from each amplifier to connect to the inputs of the splitter. It is important that the connected circuits on the splitter do not exceed the capacity of the input source. The splitter can also be used in a dual audio message configuration where two amplifiers provide separate audio sources. Each output from the splitter can be programmed to select either input 1 or input 2, enabling different messages to be played in separate zones simultaneously. This application provides 8 controllable output circuits, offering flexibility for dynamic and diverse messaging needs. The remote microphone connections on the main board require careful attention to ensure proper functionality. These connections include 2 shielded twisted pairs, one for microphone audio and one for RS-485 communication. Additionally, a third pair supplies 24 VDC power. The connections originate from the main board and are daisy-chained to each remote microphone, with a maximum of 6 supported. To maintain signal integrity, shield continuity must be preserved, and shields should be terminated only at the main panel. This setup ensures clear and reliable communication across the system. The remote mic has indicators that show power and trouble status. In addition, the mic status LED provides the user with status of the paging bus. If the LED is green, all call paging is available. If the mic status LED is flashing yellow, it means the system paging bus is in use by another microphone, and paging is not available until the light is green. The local operating console, or LOCR, is a remote station that combines a microphone with a main display for system control. It duplicates the functionality of the master panel, providing operators with full control from a remote location. This flexibility ensures that critical system functions can be accessible in multiple locations. Additional space is provided for a 24-button display adder or a remote annunciator display. The connections to the LOCR are the same as the remote mic, 2 shielded twisted pair cables, and 24-volt DC power. The local operating console can be equipped with the optional RAC's LCD light annunciator connected to a compatible fire alarm panel. This remote annunciator display provides real-time status and monitoring for compatible Secutron fire alarm control panels. By integrating the RAC's LCD light into the LOCR, operators gain control over the fire alarm system and ECS system from a single location, ensuring timely and informed responses to emergencies. This feature makes the LOCR an essential component for installations requiring extended functionality and system monitoring at remote locations. Additional resources and information about this and other Secutron Fire products can be found by visiting us at secutron.com.